Dear students, welcome to PMDC online lecture room. Today we are going to discuss the topic cathode rays. This topic is present in chapter number 2 named Atomic Structure of grade 11 chemistry book. This topic includes introduction of cathode rays, cathode rays tube, production of cathode rays, properties of cathode rays, and assignment. Let's start from introduction. Cathode rays are stream of electrons observed in discharge tubes. These rays are composed of electrons. They are also called an electron beam. These rays are so named because they are emitted by the negative electrode or cathode. They are invisible, but their presence was detected in early vacuum tubes. The early cold cathode rays tube, called Crookes tubes, used a high electrical potential between the anode and the cathode to ionize the gas. Modern cathode rays tube use thermoionic emission, in which the cathode is made of a thin wire filament that is heated by a separate electric current passing through it. The second part of our today's lecture is cathode rays tube. Cathode rays tube or a discharge tube is also called Crookes tube, which is composed of a glass. At both ends of the tube, two metallic plates are connected called electrodes. The electrode, which is connected to the positive terminal of the battery, is called anode, while the electrode, which is connected to the negative terminal of the battery, is called cathode. The discharge tube also contains a vacuum pump and a source of high voltage from 5000 to 10,000 volts. Look at this slide, on which various parts of a discharge tube are shown, that is high voltage generator, vacuum pump, anode and cathode. The discharge tube is filled with a gas or air or vapors of the substance to be studied. The exact voltage required is determined by the length of the tube and pressure inside the tube. According to William Crookes, the gas or air inside the tube did not conduct electric current at 1 atm pressure. Now we are moving towards the third part of our today's lecture, that is production of cathode rays. When the pressure inside the discharge tube is reduced to 0.1 mm of Hg through vacuum pump, a uniform glow appears inside the tube. Look at this light, in which uniform glow in the discharge tube can be seen. The gas in the discharge tube conduct electricity. When the pressure is reduced to 0.01 mm of Hg, then the glow disappears and rays are produced. Cathode rays are emitted from cathode and are called cathode rays. Look at this light, in which green fluorescence can be seen on the opposite side of cathode. The color of fluorescence depends on the composition of glass. Cathode rays produce greenish fluorescence when falls on the wall of the glass. Look at this light, in which greenish glow can be seen due to glass screen. While in the case of alumina, red fluorescence and tin stone, yellow fluorescence are produced. Look at this light. In this light, red fluorescence can be seen. This is due to tin stone screen. Here yellow sparks can be seen. This is due to alumina screen. The modern research show that these rays are not produced by cathode, but cathode rays originate by the ionization of the gas present inside the tube. Now dear student, the next part of our today's lecture is properties of cathode rays. Number 1, cathode rays travel in a straight line. Number 2, if an object is placed in their path, a sharp shadow is produced on the opposite side. Look at this light, in which the shadow of this object can be seen, while the rest of the area is greenish. Cathode rays produce fluorescence or lightning on striking the walls of the tube. Look at this light, in which green fluorescence on the screen are visible. Cathode rays heat the object on which they fall. The fifth property is cathode rays have mass, velocity, kinetic energy and momentum. They cause mechanical motion of a small pinwheel placed in their path. They have the same mass and charge as electron. they can be deflected in electric field or magnetic field. Look at this light. In this light, you can see the deflection of cathode rays in electric field. While in this picture, the magnetic field is applied externally, and as a result, the cathode rays are deflected. The last part of our today's lecture is assignment. Dear students, if you carefully watched and listened our today's lecture, then you can easily solve this given assignment. Thank you very much and take care.